Our next lesson is called Solving Equations with a Variable Expression in the Denominator. So we're going to start with a think about it. Please pause the video and think about what do the following equations have in common. Okay, once you're done thinking about that and think you have an answer, you can resume the video. Okay, think about it. What do the following equations have in common? So hopefully you saw that all of them have variables, they are equations, and they are all kind of involving fractions, but there's one of those that is different from what we've been previously solving. So it says, which of the previous equations do you currently not know how to solve? That should be the last one. This one right here with these fractions. Now, it's not to say the other ones don't have fractions. 1/2 is a fraction, y over 15 is a fraction, 1/3, 5/6, they all have fractions. But specifically, out of all these equations with fractions, the last one is a new type of format that you have not learned how to solve yet. And that's what we're going to do today. So there are actually a couple methods to solving equations that have these fractional coefficients, and we are still going to keep in mind the properties that we have been using when solving any type of equation, making sure we do things to both sides, knowing our properties of equality with all 4 operations, our associative, our distributive, our commutative, all of those are still true. Okay, so we're going to start with example 1, which is find the solution set for x, and I'm going to show you 2 different methods. Method 1 is going to be creating a proportion. Now, showing you these 2 methods, you can look at it in 2 ways. One way to look at knowing these 2 methods is to pick accordingly based on the way the equation looks. So certain methods are going to be easier based on the equation. Another way to look at this is some people decide there's one method they particularly like more than the other, and they just always go with that method. But we want to show you what your options are. So this first one is create a proportion. Okay, so when you know that a proportion means one fraction equal to another fraction. So you got numbers here, maybe a variable or number, something like that. Okay, so you have one fraction equal to another fraction where you're going to cross multiply. So as you can see in our equation right now, we don't have a single fraction on the left-hand side. We do on the right because we can put 8 over 1. So the first thing we're going to have to do is actually go back to our fraction work and make that a single fraction on the left-hand side. So our common denominator here would be 15. We need to make a 15 on the bottom. So in order to do that, the first fraction is going to have to be multiplied by 5 on the top and bottom. And this fraction is going to have to be multiplied by 3 on the top and bottom. So this is going to give us 5 times x is 5x, 5 times 3 is 15, plus 3 times x is 3x, and again, 5 times 3 is 15, which is what we did on purpose because we're trying to be able to combine them. So now that they have a common denominator, 5x plus 3x would just make this 8x over 15 equals 8. Now create a proportion. The 8 also has to be written as a fraction by putting it over 1, and now we can cross multiply. So 8x times 1 is 8x, and then if you take 15 and multiply it by 8, you are going to get 120. So now we can get x alone by dividing by 8. Whatever I do to one side, I must do to the other side. And 120 divided by 8, which we already know because that's how we end up really cross multiply just a second ago, is 15. So my answer is 15. Now here's your other option. Put or here. You've got 2 choices. We're going to go over here to method 2 now, which would be using the LCD, the least common denominator. So you still have to start in thinking the same way. What's the least common denominator? Well, we already know it's 15 from doing the previous problem. But what you're going to do when you use this method is you're going to take the entire equation and you are going to multiply it by the least common denominator. So that looks a lot like distributive property. You're going to take this 15 and distribute it here, here, and here. Now, I would highly suggest that you rewrite this with the 15s in front of each piece. If not, I tend to find that people forget one of the pieces. So that means I'm going to do 15 times x divided by 3 plus 15 times x divided by 5. And then that's going to equal 15 times the 8. So it is taking the extra step to write it out before you actually do the multiplication. And here's why I think that's beneficial. I can cross cancel now in each of the situations where it's applicable. So I can say, okay, 3 goes into 15 5 times. 5 goes into 15 3 times. There's nothing to cross cancel at the other side. So what this method offers is getting rid of fractions immediately. Because now we have 5 times x, which is 5x. 3 times x, which is 3x, because the denominators have been wiped down to 1. And then we have 15 times 8, which is 120. So I get rid of my fractions faster this way. 5x plus 3x is 8x. And then to get x alone, I would have to divide by 8. So x is still 15, just using a different method. So now something happens special with these types of equations when we have a denominator that has a variable as well. So you're going to notice example 2 looks different than example 1. Example 1 only had numbers in the denominator. We now have a variable in the denominator, which creates a new situation that we have to look out for. So this, to me, if I had to pick a method, it makes more sense to pick the proportion method because I can very easily make 7 a fraction by putting it over 1. Okay. Plus, how am I going to have a least common denominator with a variable? I don't. So least common denominator is going to work better when you have numbers on the bottom. So if I cross multiply, one important thing to remember about this is that 5x plus 10 should be grouped together as a binomial, and x plus 2 should be grouped together as a binomial. So when I go to multiply these, I'm going to write it out as 7 times x plus 2 equals 1 times 5x plus 10 would just be 5x plus 10. Now, if you want to keep it consistent so in your notes you understand that we did that, that's fine. And now we'll distribute everything. So 7 times x would be 7x. 7 times 2 would be 14. 1 times 5x would be 5x. And 1 times 10 would be 10. So then I go through my normal steps to solve an equation. I look for simplifying other than the distributive property, which would be like terms. I look on each side separately. The left-hand side, no like terms. The right-hand side, no like terms. So we go to variables on both sides. I'm going to get rid of 5x by subtracting 5x. Whatever I do to one side, I must do to the other. So 7x take away 5x would be 2x plus 14 equals, these x's are gone, and I get positive 10. Next would be to start isolating x by subtracting 14 from both sides. 14's are gone. 10 take away 14 would be negative 4. I would divide by 2 and see that x is negative 2. Now, when we go to check this, this is where the issue comes into play. So we're going to check this one. 5x plus 10 over x plus 2 equals 7. Remember to always start with the original. So now we're going to replace all the x's with negative 2, making sure we use parentheses as always when we do our substitution. So 5 times negative 2 would be negative 10. And down here, the parentheses we don't need. We just have negative 2 plus 2. So then what happens is we get 0 on top, but the problem is we get 0 on the bottom. And on the other side, we've got a 7. This doesn't check, yet we absolutely solved that equation the correct way. So this is an example of an extraneous solution. I'm going to put an exclamation point and a star. So in actuality, the answer to this is not negative 2. We don't have a solution, so we're going to make the empty set. So if you have a variable in the denominator, you have to watch out. You need to check the equation, whether the directions say to or not, because you could end up solving this correctly, but getting an answer that's not going to work because this is just an equation that has an extraneous solution. Right, now let's take a look at example 3. Solve and check for the value of x using the method that works best for you. So you can choose whatever method you'd like. If you'd like to pause the video and try this on your own first and then check back with me, you can, or you can follow along. Okay, so we're gonna solve this and figure out the values of x that would make it true. In my eyes, this is better to be a proportion problem. I'm just gonna make sure I have my binomials linked together, and then we're gonna cross multiply. So I get x times x minus 3 equals x plus 1 times x minus 12. So distributive on this side, x squared minus 3x equals, and then we have distributive or area method on the side over here. So x times x would be x squared. X times negative 12 would be negative 12x, and then we do 1 times x, which would be plus x, and 1 times negative 12, which would be minus 12. So really we have x squared minus 3x equals, when I combine my like terms, I get x squared minus 11x minus 12. So then I'm going to get rid of my x squareds by subtracting them. Whatever I do to one side, I do to the other. So negative 3x equals negative 11x minus 12. So now I have variables on both sides in what I like to call a lopsided equation, which means there's 2 things on the right side, but only 1 on the other. So you want to get rid of the variable on the side with more stuff by adding 11x to both sides. So you're going to have 8x equals negative 12, and then divide by 8. So you end up with negative 1/2. Now, the real issue with checking this is the fact that we want to look out for that extraneous solution, okay? So even without doing a full check, which I'd rather not do just to keep the video shorter, you would want to take negative 1/2 and plug it in, which you can try completely on your own. But as long as I know I'm not going to run into an issue with the denominator, I'm okay with skipping it now in the notes. So negative 1/2, if I put it in for this x, I'm not going to get 0. And if I put it in for this x, I'm not going to get 0. So I know that my solution is okay, and I'm going to get negative 1/2. Okay, now I want to do one last one. Now again, just to keep this video short, we've already done one check. You can do the check on your own at some point to make sure that it really works. We're just going to solve. So I want to talk about this one because it is something I want to use least common denominator for, but you also have some binomials at top that we have to address. Okay, so I'm going to make sure these go in parentheses right away to keep them grouped together. My least common denominator, I could do 6 times 10, which is 60, but actually there's a smaller one, 30. 6 goes into 30, and so does 10, and you'd rather work with something smaller. So I'm going to multiply this entire equation by 30. That means in all 3 sections. So remember my suggestion, rewrite it so that you have all the 30s you need. So you really have 30 times 2x plus 7 over 6. Then you have minus another 30 times 2x minus 9 over 10. And then you have 30 times 3. So again, if we do it this way, we can cross cancel. 6 goes into 30 5 times, 10 goes into 30 3 times, and we can't cross cancel on the right. So you need to keep that 2x plus 7 in parentheses. We have 5 times 2x plus 7 minus 3 times 2x minus 9 equals 90. So right away, we've eliminated the fractions. Now we can simplify by doing the distributive property in these 2 places. 5 times 2x is 10x. 5 times 7 is 35. I like to think of this as negative 3. It's easier because then you're taking care of the leave, change within doing the distributive property. So negative 3 times 2x would be negative 6x. Negative 3 times negative 9 would be positive 27. Then we're going to look for like terms. I don't have any on the right, but I absolutely do on the left. 10x and negative 6x would make 4x. And then 35 and 27 is going to give me 62. So now we would be subtracting 62 from both sides and get 4x equals 90 take away 62 would be 28. To get x by itself, we'd want to divide by 4, so x equals 7. Now again, you can take your own time to check. We don't have to worry about an extraneous solution because there's no variable in the denominator. So this concludes your lesson on solving equations with a variable expression in the denominator.